Hi, today we're going to look at survey and sample. So often when we do surveys, we don't just survey absolutely everybody in the world, we just take a small sample and survey those people. Why do we do this? Because a small sample, as long as we select those correct, they can actually give us a good indication of what the population think or what their responses could be. It's going to be really costly to sample, or not sample, but to actually interview or ask questions to everybody in the population. This very rarely happens, but it does happen in some cases, such as the census that we do. That occurs about every 5 years. Clearly you can see the Australian Bureau of Statistics collect this because, well, it is statistics, and after all they collect information off every single person and just display it in a way that everyone can see. So this data set is really big. In 2016 we can look at that we served, how many people we actually interviewed. It was about 23,400,000 looking at the percentage of males and females. The average age then was 38. Quite interesting. I'm considered quite young. So you can get a lot of information from this. So this went out to every single household in Australia, and everybody had to return a form filling out information from basically their backgrounds and asking a lot of personal questions. This gives us an accurate snapshot of everybody in Australia because we've asked every single person in the country exactly what they're doing. And as long as they answered correctly and truthfully, it will give us a really good indication of where we're at. This is really costly. It costs a lot of money to put a survey out there and then also get the responses back. You've got to mail everybody, so it's going to cost a lot of money for the government. Hence, we only do it every 5 years. Typically, when we're running governments or anything like that and they want to get a bit of an idea of what's actually happening in the market, they will choose a sample. And this sample could either be randomly chosen, or it may be a target specific area that they want to actually, of age group, for example. They might want to choose, retirees and just look at those. They might want to choose retiree males. But typically, if you want to sample the whole population, you might choose just a random generator. You'd probably want to have younger, older, male, females, all in there as well, and get a bit of a sample around Australia as well. So you're not just focusing on one state. You might want to get people in different states, obviously, and different towns and major cities to get a really good indication of what the general vibe is of happening. So as long as this sample is big enough, it should represent what the population is, but data never does that, and it sometimes can actually be misleading from the sample because it just may have been chosen the wrong people to represent what the Australian population looks like. So hopefully that gives you a bit of an idea what the difference between a sample and a population is. It really depends is the question that we're asking everybody in that community, or is it only asking a few people in that? And that's really the difference. If it's only asking a few people in that community, it's a sample. If it's asking everybody in that community, it is the population. Clearly, a population data collection of population and asking people to the population is going to be a lot more accurate than the sample. But if the sample size is relatively big enough and it's been accurate enough in terms of that you've asked a wide range of audiences that you would normally ask within your population, encompasses everybody, then that will show you a pretty good indication of what the population would say too. So a population doesn't have to be as big as Australia, for example. I mean, we could say what the population, we could use a survey that would be the population at East Doncaster Secondary College. We could ask a question at your specific school and ask about the canteen food. What do you think about the canteen food just at your specific school? And that would have to interview every single student and staff member, everybody who can buy food at that canteen, to really find out, do they think the food is of good quality? And we could ask a survey, something like that. Now, if we wanted to get a snapshot of just, let's say, what was the canteen food like at every school in Australia, then we would need to ask to get the population, every person who's at a school, ask them and survey them. But normally we do a sample. So we might ask 20 schools in each state, and we might try and get like different year levels, also going in the primary schools too. So just to try and get an idea of what's happening there. So that is the difference between a sample and a population. If we're asking about how you felt or how your canteen food was at your school, and we only asked a few people from each year level, that would be a sample. But if we're asking about how you felt about the canteen food, just only looking at your school, if we asked everybody in the school, that would be the population. So really, if you miss out on a few people from getting the survey and they should have been surveyed, that's actually a sample. But if you include every single person in that survey, that's a population. And that's the easiest way I can explain it. So the accuracy of the results of a survey really come down to its size. I mean, if you get everybody obviously in the population, it's going to be a really good, accurate representation. But normally the sample size, the smaller it is, the less accurate it's going to be. Also, you need to have a diverse range. You need to cover every single person or who could possibly be in here should be in there. I really like this diagram because you can see all the different colors could represent like maybe different sexes and different ages, and notice that we've actually got a good range of those people that are in the outside. Now, for example, if you went to say, hey, how do you guys feel about the canteen food at your school, and you only interviewed Year 8 students, that would be completely incorrect, because that is biased to a Year 8 point of view. Now, Year 8s may be a bit more picky, they might not actually enjoy, they want more junk food, but the senior kids actually prefer maybe more health food, therefore we're not showing an accurate representation of what the actual school's perception is on that. I don't know why I'm picking on the canteen so much, we can choose a lot of other things, but it's just something that can be relevant to you. So we should look at a few key words. A sample is a subset of a population. That means it's not the whole thing, it's actually within that. Again, just like this picture, it is within the whole population. It is a subset of people within that. Notice we use the word already, census, and a census is the entire population. That's actually what that word means. It means you've actually interviewed or you've asked a survey from everybody in that population. Sample size refers to, well, what's the size of the sample you took? So in this case, we just add up how many people we have in the sample, and I think there's about 20 people there, and note we've got some smaller kids in there, we've got some older kids, and so on. So we always need to question whether or not the sample is actually representative of the large group as discussed, or is it biased, which means that there really is one outcome more likely than the other because of the people who you've actually selected. So the accuracy of the survey can sometimes be biased, so that's why you've got to get a really good representation in your sample. And that will then change a whole lot of like what your average is, you know, your spread of your data and everything as well. So typically when we look at data, we can describe it as different types of shape as well. So once you've done your sample or your population, symmetric, why we call it symmetric is if you put a line right down the middle, it can be folded in on itself and it looks exactly the same. If it's skewed, we have two types of skewed. We've got this skewedness, because if you think about it, it'd be like a chicken skewer. It sort of skews off to the bottom there, and this one skews off to the bottom here. We can actually call this one negatively skewed because it's skewing towards the negative numbers, because obviously this is going to be higher, more positive, and this will go towards the negative numbers if this is the axis here. So that's going to be negatively skewed, where this one here is skewing off towards the positive, so that we're going to call that one positively skewed. Now, don't forget what we talk about is mode. Mode means the most common or the highest number. Now, clearly I can see that this number here is the highest, but also this number here is also the highest. I have two of them. Like anything, two, another word for two is bi, like bicycle, it has two wheels. So we call that bimodal, or two modes if you want to call it, but we actually call it bimodal. Let's give it the respect it deserves. And that actually represents that there's two main modes, which means bimodal. So when we're using this, we really want to use the median, I should say, in skewed data or bimodal. What we do want we'll only use the mean when it's symmetric and there's no outliers. Other than that, you would always use the median if there's an outlier, because it doesn't get influenced by the shape or the skewness, and it will show you a better measure of the average. The mean is really affected by outliers or by skewers, and it won't represent the average as well as the median. So when we're choosing the median number, you'll pretty much use it all the time and you'll be fine. The only time you will use it if your range of data looks, when you display it in a histogram, is symmetrical. So let's just go through building some of your understanding. Mariko wishes to know the average age of drivers in her city. She could survey 10 of her friends or survey 1,000 randomly selected. Which of these options would give a more accurate result? Well, I wonder. Have a think about that one for yourself. Hopefully you've thought about this and you're going, well, 10 of her friends are probably going to be biased because they'll probably be around about her age, and they want to know the average age of drivers. If you go 10 of her friends and she's 21 or whatever, they're going to be like, oh, the average age is 21, which is completely incorrect. I mean, if you stopped 1,000 cars randomly and just asked them what your age is, you would get a better accurate measure of what the average age is of a driver. Which would be easier for Mariko to perform? Well, clearly asking 10 of your friends is going to be a lot easier than standing in the middle of the street waving down 1,000 people going, hi, how old are you? They may look at you a bit strange too, and you might go to the police station too. I wouldn't suggest doing that yourself, so it would be a lot easier for you to do it, but this is the thing about actually collecting data. It's never easy to get a good representation of the population, even if it's a sample, but you need to get a good spread of data there, of people who you're surveying. Ajith looks at a random sample of penguins and notes that of the 50 he sees, 20 of them have spots, okay, on their bodies. So what is the proportion of the population that has spots? So if we think about it, 20 out of 50 would be 2/5. We've got to simplify that down, 20 over 50. So we can think of 20 over 50, because 20 of them have spots. We can divide both of those by 10, which leaves us with 2/5. So the proportion would be 2/5. Alternatively, you could put in a percentage as well. which you can do 2 divided on a calculator, or you can make the denominator up to 100 would be another way you could do it for this question here, which would then turn into, obviously, what are we looking at, 40 on 100, so that would be 40%. So you could say 40% or 2/5, which is exactly the same thing. So moving on, if there are 5,000 penguins in a region, on the basis of this sample, so we're talking about this sample is done, how many would you expect to have spots? Well, we're talking about 40% or 2/5 of the proportion. So all we really need to do there is just go, well, we've got 5,000, and of that, of meaning multiply, of that we have 40%, which is, we can either multiply it by 2 on 5, or we can multiply it by 0.4, which would give us, well, if you think of 10% of the proportion, that would be 500, and you've got 4 lots of 10%, which would then need about 2,000, which, if you think about it, it's a bit under half, and 40% is a bit under half, so 2,000 I'd expect to have spots. So this is where we can sort of do a sample of something, then we can look at like a different region, and we can maybe like then use that data here to apply to another scenario and scale that up. If there's 500 penguins in a region, how many do you expect to have no spots on their bodies? Well, we know that 40% have spots, obviously 60% don't. It would be 60% of that 500. So in that case, we're looking at, I think, about 300 there. So how you do that is you'd go 500 multiplied by 0.6, or you can think of 10% is 50, so 10% times 6, because that would give you 60%. 50 times 6 would give you 300. So there'll be 300 penguins there. The other part you need to be doing is like, how do we look at these results and how to interpret these? Again, when I first look at this, I see, this is obviously a histogram because I can see frequencies on the side. It's not a percentage, it's a count. So I've got 50 with number of children down here. So 50 people have no children, I can see. Notice the zeros in the middle indicating it is the exact value. Now, how many people have 1 children? 20. How many people have about 15? We've got with 2, about 10 with 3, and about 5 people have 4 children. So I always have a quick look at the graph and try and understand what's going on in this place, and that makes a bit more sense for me now. So now we're going to move on to the question. A survey is conducted asking 100 randomly selected adults how many children they have. So it's really good that they've said randomly selected. That means it's not biased. They've actually gone in and randomly done that. Normally, if we do it randomly, it won't be biased and if you do a big enough sample size, everybody will be included in there, including range and demographics. So the results are shown in the graph above. Assume that this sample is representative of the population. Awesome. They've already given us a hint there saying, hey, it's pretty good of the population. What proportion of the adult population has 2 or more children? Well, if this is the population, we're saying has 2 or more, so that includes 2 or more. Well, if you think about it, now we've got to add these up. So the easiest way to do this is I always just put a bit of a mark on the top. So we've got 15, we've got 10 here, and then we've got 5 here. So how many do I have in total? I've got 20, 30. I've got 30. Now, don't forget there was actually, I think, 90, there was 100 randomly chosen out of this survey. So 30 out of 100 adults in the survey actually got 2 or more children. Well, that's already a beautiful percentage for us. That's 30%, or we could also say it as 0.3, which really helps us with this part of answering the question. So in what proportion of the adults have 2 or more children? Well, we can say it's 3/10, or we could also say it's 30% there for this one. So we can answer either of those. In a group of 9,000 adults, how many would you expect to have 4 children? So how many do I expect to have 4 children? Well, 4 children, we're just saying only 4 children, is 5 out of 100. So that's really what we're talking about, is 5%. We're expecting of, if this is relative of the proportion, 5% of the population here has actually 4 children. Now that's like, so if we got 5% of 9,000, or if you think about 10% of 9,000 is 900, and half of 10% gives you 5%, so it's 450. Here it's not asked how many, what percentage, just be careful. It says how many, implying like how many adults, okay? It's not asking for a percentage, or it's not asking for the proportion, it's asking for actually how many. I would actually say how many adults, but it's implied there. So the answer for that is actually 450 people, or 450 adults to be more accurate, have 4 or more children. Is this distribution symmetric, skewed, or bimodal? Well, looking at it, I mean, I can't fold it in half. I can't put a line here and just fold it. It doesn't look good. we can see that the shape of this is actually skewing that way, and it's skewing towards the more positive numbers because that's obviously positive and this way is negative. So we can call this actually positively skewed because it's skewing towards the positive skewed. Only looking for skewed as an answer, but you should know the difference between positive and negative skew. Which of the following methods of conducting a survey could lead to bias? So being biased, so unfair really is what we're saying. We're talking about bias. It hasn't represented everyone correctly. Asking people waiting outside a child centre.